Introduction to ZIG. In Learning ZIG, Session 3, let's cover arrays and slices. ZIG's array syntax and behavior matches that of C. Array length in a pair of square brackets, followed with the only data type of which elements will be contained, with curly braces following the type. It does allow use of underscore character in place of array length as for const ls, to infer the length with count of elements in following curly braces. Let's just give a quick try to it in our sample hello world code. We'll add a new function for it in root.zig. Create two arrays A, B, and C, D. Make return type void and discard the values for now. We'll have to tweak the data type to allow 1000's values. Let's return a comparison among two values of these arrays. A quick ZIG run to check where we at. Let's write a basic test for this. And also let's change it to pass lists to this function and do an all-value match. There is this ZIG by example site with few good basic flow examples that can be used as a quick reference. I'm using it for reference of getting an index range while looping thorough elements of a list, where I'll return fouls if any element doesn't match at other arrays' same index element. Oh, I understand it's getting passed as slice, but that not being allowed is a bit funky. Let's check some search threads on such failures. I think this has something to do with our function being public exported and falling in realm of C calling conventions. Now don't worry, passing arrays in simple non-API exported function
CD
works,
arrays length
but this way you'll
via
remember what
underscore
not to do. So I can write separate function or maybe do some pointer mismatch, but we are just in early learning phase, so let's just stick to simple flows. I'll make it a dumber example. Changed function name to ABCD, as the array flow made us cry. Also tweaked CD arrays length inference via underscore character. Removed the function and test from root.zig and moved it to main.zig. Actually, let's move it main.zig for now, to keep it simpler as for now. I'm sure we'll explore the library exported flows as we have a better understanding. A quick ZIG run to check where we at. Array element selection by index is as in other traditional languages, so we can use the index we get in our loop. 0.3 gives us a slice of array AB. Here, I call 0 as start index and 3 as end before index, as this picks elements from 0 to 3-1, so that would be 0, 1, and 2 index elements. We can also use startIndex ... with no end before index. That will capture all elements from start end to end of array. A slice object is combination of pointer to first slice element and length of slice number. Here, giving len attribute to slice objects allows ZIG compiler to check if slice is in bound or not. A quick view at array operators. These only work when the operand lists have compile time known lengths. ZIG has two of them, ++ operator concatenates two arrays, so you can join two lists of numbers or two strings into one as simple. There is an array multiplication operator as double asterisk. This works on an array and a number. It replicates the array by the count of provided number and concatenates them. Checking these out in code. Tweak some value for CD so we can identify when working on them. First, let's print the len of array just as a mental hook. I forgot to add placeholder for interpolation. Now let's print array concatenation for AB and CD. Now array multiplication for AB and CD wouldn't work, as it is for repetition of an array by a count. So let's give it a count for AB multiple. A sample of string multiplication using array multiplication. Now let's see difference for if slice's length is known at runtime versus compile time. Some pointer operations like dereference of pointer is only available to slices if their length is known at compile time itself. If range of indexes isn't compile time known, the slice object created is not a pointer anymore. As in the case of following GPA allocator created slice, the range is runtime dependent on the OS it's ran on. General purpose allocator is one of few heap memory allocator patterns in ZIG provided by stdlib. It has thread safety and allows you to retain memory outside the scope of function stack. Let's do a quick write and run for this so it settles down in memory lane. Instantiate heap's general purpose allocator. Now calling allocator function on this shall return a pointer and vtable reference. Init a usize variable for required runtime inferred size. Then allocate heap memory to a const buffer. Creating slice with it that has runtime identifiable length, then discarding the value as we have nothing to do with it yet. A typo with try statement here. Nah, let's add it directly in main.zig for now. Add the call and run it. This is it for this session.